This is something you never want to see around a furnace or an indoor air handler. If it's a water puddle on a garage floor, that's not too bad. But if it's in an attic or in an enclosed closet internally in the house, this kind of puddle can cause major structural damage. Careful consideration needs to be given to condensate piping and how we are going to route the condensate outside the home. If you are constructing your own trap for a furnace or an air handler, you need to follow the general rule of thumb that on the outlet it needs to be a 2-inch depth or greater, and on the outlet of the trap a 3-inch depth or greater. This overcomes the positive pressure that the blower on the air handler or furnace produces, which will hold the condensate inside the unit and not allow it to drain out properly. There are many pre-made traps that you can purchase to put on all kinds of equipment. Just make sure that it has the proper depth. Never use a shallow running trap, as this will not provide the depth of the trap that will be needed for proper draining of the condensate. This is a diagram out of a major manufacturer's installation guide showing the negative and positive pressures on a blower. You'll notice that in the blower cabinet there's negative pressure as the blower is pulling air into the cabinet. Once the air is discharged out of the blower housing, in the furnace and in the evaporative coil, there is positive pressure which is then exerted into the condensate. Make sure that the condensate does not have positive pressure, as this will not allow the consistent flow of condensation when the drain is at a positive pressure. On most furnace applications, you need to have an open standpipe for the condensate. Make sure that you put a T in with an air gap to make sure that the condensate flows freely out of the furnace. But as always, refer to the manufacturer's installation guide for their recommendations on the construction of the condensate trap. Once again, in this diagram, you see the positive pressure that is exerted on the condensing furnace and the evaporative coil, and how it extends into the condensate piping. Having an open standpipe on both the coil and the furnace reduces that positive pressure and allows the condensate to flow freely from the coil and the furnace. This diagram shows a separate condensate drain pipe for the evaporative coil and for the condensing furnace. In some applications, you may not be able to run a single condensate line, and in this case, you would want to have an open standpipe and would run the condensate as depicted here in this diagram for this particular application. These diagrams show how not to do it. By running a closed condensate trap, you may withhold the condensate in the evaporative coil or the condensing furnace, and that would cause a problem with the proper flow of condensate out of the unit. Most of the directions and diagrams that we have given in this presentation have been based on a Carrier Bryant furnace, which has a trap internally located on the furnace. If this is the case, you do not want to double trap the condensate, and so this is why you would need an open standpipe on the outlet of the condensate drain. But as always, consult the manufacturer's installation guide for directions on how to set up the condensate. As we stated previously, once the condensate has left the furnace or the air handler, then you either need to gravity feed the condensate to outside the home, or you need to run it through a condensate pump, which will then pump the condensation outside the home.
Go to arefco.com for more videos. Like, subscribe, and check back every week for new videos.